In this video, I will be going to discuss about one of the sorting technique which is known as counting sort algorithm. So basically in counting sort algorithm, there are two versions. One is linear algorithm and it is useful for small files, but it is not adaptive for the object oriented sorting. For example, if I have student of marks, in that case student dot marks, if I call that member from that object, then it goes to the error. Why? I will tell you about it, because the coding in such a way that we can't override that particular indices or parameter or member function into that. So there are two versions. One is normal version, primary or naive solution, and next is optimization version, or we can say that general purpose implementation. So first discuss about time complexity. The time complexity is big of n plus k, where n is number of elements and k is a range. Range means if the number which is inside that array is 4, then my range is k, because I have to largest element is 4 and my range is 5. It is a linear algorithm because the time complexity is big of n. That's why it is a linear algorithm. It is useful for small files. Whenever there are least number of elements or small number of elements, then it is useful. And here I consider one array which is 144101. So there are duplicates also. And value of k is 5 because the last or the greatest element in this case is 4. So my k is 5. So here I'm considering count array, as name itself suggests that it is counting sort. We have to count that number of duplicates and we have to arrange in such a way. So count here tells us about how many time that particular number came into the picture. For example, one is came into the array into is 3 times. That's why in index 1 I write over there 3. 4 is coming 2 times, so that's why index 4 I write over there 2, and 2 or 3 are missing, so that's why I write into count array that is 0 0, and 0 is coming only 1 time, so that's why at index 0 I'm writing over there 1. So that's how the strategy. The elements are repetitively manner, and we have to write those indices, means how many times they are coming into that particular array. So there are two array, one is which is we taken as a parameter, and the second array count, which we have to take care about how many times the particular particular element is coming into the array. So that's it. After sorting, as we see, the array is sorted. And how this algorithm works: first it increment the count array, it go through the array, and in count array it just increment how many times that particular number is occur. For example, if 1 is 3 times, that means that there are 4 number which are less than that of 1 in that particular case. So we have to put that 1 into the index 4. That okay, you understood? So if 0 is coming into the picture in the array, and if in count is that in index 0, that is only 1, that means 0 is the only element which is present in that array, which is not any element having greater than that of 1. So that means we are putting that element as in the index 0th index. So that's how the counting and sorting work side by side. So we have to code that. First void counting sort. As usual, we have to take one array because we have to work on that. Then there are two parameters. one is array itself, second is number of elements, third is how many times or the largest integer in that particular array. It is for integer only, that's why it is naive solution. So we have to take one array of size k because largest index is k. Then we have to go through a loop which is from I0 to I less than k because the largest size of that k of the count index is k. That's why I write here k. And then we have to store count of I equal to 0. That means first we store all the elements or indices of that count into 0, and then we iteratively go through the array and change that number 0 to some other number, that is 1 3 as you saw on the screen. Then I less than n because we have to pass through the array itself. Then count of array of I, we have to just increment that, it is just indexing. And then we have to take one index parameter and store it as 0. And after that we have to take one for loop which is going from 0 to k because there are kth largest index. So I is less than k, I plus plus. Then we have to go through iteratively to each number and check if that index is present in that particular array. Means for we consider here element as index, and the array element is the number of time that that particular element is present in that array. So int I is equal to 0, I less than count of I plus plus. So in this case we just store index is equal to I and index plus plus. That's it. So in first two for loop, in first for loop, I just set all the count elements to 0 because first time there are no elements. Then in second for loop, I incremented the each 0 by how much time? By the time the numbers are repetitively present in that particular array. For example, I'll show you. In array there are 1 2 3 three ones, so that means at index 1, this index, it should present 3 because in this for loop we did that, we just incremented that count of array of I plus plus. That means for first one it should be 1, then second one it should be 2, then third one it should be 3. Likewise, if 2 and 3 are not present, that's why I put there 0 0. And 4 is as you see 4 is 2 times. In index 4 I write here 2. That's how the counting sort algorithm works. It just counted the number of times particular element is present, and below that elements how many elements are present. That is the strategy to count the elements. So we have to check the output by taking one sample example. So elements are 1 4 4 1 0 1 0 1. We have to call counting sort array number of elements and largest index or largest element. Then to print it out, I less than 6, I plus plus, array of I. That's it. We have to check the output for the naive solution. Okay, it's showing the error. That means we did something wrong in the code. Okay, so just dry run the code. First int I is equal to 0 less than k, that's it. I less than n, I 0, I less than k. Then inner loop, which is count of I plus plus, array of index is equal to I index plus plus. Okay, all the things are right, but what happened here? Okay, we have to take here J because I already is fixed into the position. Let's check the output. Okay, that's it. It is running well. As you see, the elements are sorted. Now go to the second part, which is the general purpose algorithm or general purpose implementation. So what it does actually, I take here array and count also. It's same as a knife solution. But what happen at each iterative call, the values of array count decreases. What that means for count one, if I found that one is placed at its position, that is index 4, then automatically this decreases and its value going from 4 through 3, then again 2, then again 1, then again 0, likewise it just decreases. And that's why I write here one, or I will take the output array for the storing of these elements. And as you see, count is equal to 0 0 0. At last all the count elements which are starting as a 0, we put it as a 0. At last also they will become a 0, and that's how it shows that all the elements are placed at its original position. So let's try to code it. So int main, we first take one array of element 6, then 1 4 4 1 0 1. So that's it. So menu driven function is ready. So we have to start with declaring the function, which is array, same parameter. And like knife solution, we have to take same parameter. Just changes that instead of index, we have to take care about object oriented programming. So that's why we take here output as array. I will show you how. So int count of k, it is same as a knife solution. Then I is equal to 0, I less than k, I plus plus, and again setting all the elements of count is equal to 0. Then next for loop I is equal to 0, I less than and I plus plus. Setting again all the count of array of I is equal to I. That means creating a new indices. That's it. Hereafter the picture will change. Instead of taking index as a storing number, we have to take care about object oriented. That's why I take here one of the array as output, and after that you have to take for loop int I is equal to n minus 1, I greater than equal to 0, I minus minus. So why I write here n minus 1 to 0? Why I'm not taking 0 to n minus 1? Because if we want our algorithm to be stable, then we have to start from the last index. That's why. So output of count of array of I minus 1. You have to put that equal to array of I. Means each time we have to decrement our count index by how much? By arrayth index. And after that, if this will happen, we have to store all the output elements into our array elements, which we want to return as a output. So I less than n, I plus plus, array of I is equal to output of I. That's it. So code is ready. I will tell you about dry run of this code. So as we can compare both the codes. So first counting sort algorithm, in first code in naive solution we just take 2 for loop, and here also we did just take 2 for loop. Here we take 2 for loop to settle down the count element as 0 and then increment it. Here also we did the same. But what will be the difference between this and this is that we take here, instead of index we take here output of array to take care about object. So I'll start here from n minus 1 to 0 and output of count of array of I. So I'll tell you what exactly it is. It means if I check that my index which is 4 here, so 3 here, for which element? For first element. Means there are 3 ones, so that's why index here is 3. And if 3 will I just increment here and decrement by 1, and that count of array of I minus 1 I'll store into the output and then store into the array of I. So at each iterative call, the output of array, the last output, so I'll tell you how output will look after the passing of all elements. So first index is 0, then 1, then 1, then 1, then 4, then 4. Means it is sorted. It is not sorted in one go. First, what happens? Counted sort. First, check that how many times the first is coming. So it is 4 times. So at index 1, 2, 0, 1, then 2, then 3, then 4. Then 4 it will put 1, and after that it search for other elements. And if I put here 1, that means I have to decrement the 4 as 3. and then again if I put another one, I have to decrement this too, and this is code for that. This is code for that decrementation. So that's it, we have to run the code. Showing error, okay. Showing error, count does not a name a type. Okay. We have to take here one bracket also. Okay, I'll write down over again. Count of array of I minus 1. Okay, I think now it's going to run. Okay, again it's showing some error. You have to debug that. Okay, you have to decrement also. Then it's showing error. So let's start from the starting. So first I start with I is equal to 0, then k means starting count all the elements are 0. Then after I incremented the index, means this step I did in second for loop. Then output I declare okay. Then I is equal to n minus 1, I should be greater than 0. This is also okay. Then output of count of array of I minus 1 means at each time I decremented my index, and that particular array of I element I store into the output, and I decremented count of array of I. Okay, this is also correct. So logically it is correct, but I think syntax error are there. So let's check again. Count does not mean time. Okay, so count showing again the error for count. Okay, I got it. Why this is showing there? So we have to take care about count also. That's why count is showing error. Because I didn't fill the array with the indices, and before filling the indices I just subtracting. That's why it is showing the error, because there is nothing to subtract. We have to first put element into that particular count variable, and then we have to subtract that. So that is my mistake, my bad. So int I, count of I minus 1, count of I think this is right code. So just check it. Okay. After so many error and debugging the code, at last we get our output sorted. That's it. 01144. So thank you. Like, share, subscribe if you want my coding style and explaining. So thank you. Stay blessed.